Okay, good morning everyone. So myself Devobroto Kumar Das from Dumka Engineering College. Today we will go the subject that is control system. Okay. And today is 4th January 2022. So am I audible? Please confirm me anyone. Am I audible or not? Subhasis? Am I audible? Please confirm me anyone. Am I audible or not?
Yes, sir.
Okay. So very good morning. So I am Assistant Professor Devobroto Kumar Das from Dumka Engineering College, and I am take the subject that is Control System 1, and today is the 4th January 2022. Okay. So everyone please write your own name and roll number in the chat box also. And right now, okay, so let's start. So last class we have discussed that is stability analysis of control system. Okay, so we are giving that is a little bit idea of the stability analysis in our control system. So I am discuss introduction part of why stability is a requirement in our control system. Then we have to discuss the another part of the different types of controls stability criteria in control system. Okay, so first of all, the stability analysis, it is a basically feedback control system. It is based on identifying the S-plane location of the roots of the characteristics equations. Okay, so when you have to consider, we have to so just wait, I am sharing my screen. Okay. So we have discussed, this is module 3 our, okay. So module 3, that is the stability analysis of the control system. So my whiteboard is visible, all of you? So stability analysis, it is a basically feedback control system. So the stability analysis of a feedback control system is based on identifying the S-plane location of the roots of its characteristics equation. Okay, so the stability analysis of a feedback control system, it is based on the identifying the state of the plane, that is a S plane, location of the roots of its characteristics equations. So that's mean when you have to consider, that is the, we have to learn previous module, that is the first order control system, second order control system, and also third order and also higher order control system. So when you have to consider the characteristics equations, so this stability analysis of a feedback control system, it is basically based on the identifying the S-plane location of the roots. This root, that means when you have to consider the so little bit my here network is unstable today, so that's why little bit disturbing. So 1 minute. Okay, so please everyone wait for 5 minutes because I am restarting my laptop, then I am starting. Okay, so please everyone, please join after 5 minutes. So the stability in terms of characteristics equation of a control system. Okay, so if the order of the characteristics equation, basically we have to consider in our higher order control system, this is basically second order and higher order. Just wait 1 minute. Okay, so my slide is visible, everyone? Please confirm me, anyone? Slide is visible?
Yes, sir.
Okay. So we have discussed that is the stability of the control system. Okay. So we have learned in previous module that is a different types of order of the system. That means we have to learn the first order transfer functions, second order, third order, and also higher order of the transfer functions equation. So in this characteristics of these equations in any feedback control system, when you have to needed the stability analysis, it is basically based on the identifying. So first of all, we have to know that means why stability is requirement in our control system. So system, it is stable if for a finite input the output of the similarity finite value. Okay, so this is the basically main requirements why stability is requirement. Okay, so this system, it is stable if for a finite input the output is similarly that is finite. Okay, and also this system which is stable must have all its poles in the left half of the state of the plane or is plane. So this is the basically. Okay, sorry for that. Today's network, it is very disturbed. So college network and also my personal network, it is so disturbing. So again, this class is again and again it is cut. Okay, so I am repeated once again, that is stability analysis. It is a basically feedback control system is based on the identifying the S plane, location of the roots of the characteristics equations. So when you have to consider any order of the characteristic equation of the control system, so you have to follow the roots of the most of the roots, it is present on the left half plane of the S plane. So that's time you have to tell the system stability is very good. And when we have to consider the other poles or roots is the present in the right hand plane or imaginary axis, that means this system, it is not stable. So this is basically stability analysis of control system. So a system is stable if for a finite input the output is similarly is finite. Okay, so this system which is stable must have all its pole in the left half plane of the S plane. So in the corresponding of view, we have to classify this stability into three categories. First of all, stable system. Number two, that is sustained oscillations or marginally stable. And number third, that is unstable. And this stable system, marginally stable and unstable, it is dependent on the time response and location of the roots of the characteristics equations. Okay, is it clear, all of you? So this stability, it is basically classified into three categories of the given characteristic equation. First of all, that is stable system. Number two, marginally stable system. Number three is the unstable system. So these three categories, it is characteristic equation, it is depends on the time response and also location of the roots of the characteristics equations. So when a system which roots or poles, it is present basically left half plane of the S plane, then the system, it is called the stable systems. Okay, next. Okay, so now all of you seen this picture. This is basically closed loop poles and response of the two system, that is the one is the stable system, another one is the unstable system. Okay, so first picture here you can see this is the basically stable systems. Okay, so we have to graphically represent, that is the pole. Here you can see this is the basically left half plane, that is the LHP, and this is the basically right half plane, that is the RHP. Okay, and this is the basically imaginary of the axis, this is the positive and this is the negative sides. Okay, so this is basically stable system of the any closed loop system, that means the feedback systems also. So when you have to consider graphically represent. Okay, so here you can see this is the basically closed loop pole system. We have to represent here two system, one is the stable system, another one is the unstable system. So here you can see this is the basically x-axis and y-axis. This is the 0 point, this center point is 0 0. This is basically left half plane LHP, and this is the basically the right half plane, that is the RHP. And imaginary axis we have to consider this y-axis also. So this system we have to classify it here two. One is the stable system, another one is the below, that is the unstable system. So most of the poles, it is present on the LHP, that is the left half plane. Okay, so when you have to represent the graphically response, it is basically time, and this is the basically value of the poles of the system, stable systems. So when a stable system, here you can see starting point 0, then it is increasing orderly, peak value we have to measure here, then it is decreased, then it is negative, then this is the basically stable format. In the once upon time, that is after few time or few seconds, this is basically stable of the system, that is steady state result. Okay, so when any characteristic equation, most of the poles are present in the left half plane, this system. And when here you can see this picture, this is basically an unstable system of the closed loop pole system. Here you can see one pole is present in the right half plane, another one is the left half plane, and another one is the right half plane. So the system, it is unstable format. So when you have to consider graphically response, here you can see with respect to the time, this is the 0, that is the positive region, this is the negative region. The starting point 0, it is starting, then peak value we have to consider here, then it is 0, then again. So here you can see the value is changes according to the given required equation, characteristic equations also. So the system result is not stable. Okay. So after the timing, you have to consider the certain seconds. So most of the plane, that means when a system poles its present also left half plane and right half plane, the system it is not stable. Okay, so this is basically the stable system. Another one is the unstable system, and another one is the marginally stable. That means sometime it is also working in, it is the basically the stable format. Another one is the unstable format. So this is basically the sustained oscillation of the marginally stable format. Okay, so it is clear all of you. Up to this part we have to discuss what is stability criteria, what is the basic classification of the. Okay, so everyone please write your own name and roll number in the chat. Everyone please write your own name and roll number in the chat box also. And Gautam is present. Please respond me, Gautam. Gautam is present. Okay, Gautam is not present. Okay, so anyone please respond me. Okay, Sandeep, are you hear me, Sandeep? Sandeep, are you hear me?
Yes, sir.
So please take a screenshot of the participant list, okay?
Okay, sir.
Okay, so after this part, we have to consider the stable system and unstable system for the closed loop control system. Next, here you can see, this is the basically one closed loop system. We have to consider here, this is the characteristic equations. So this is input, that is the RS, and this CS, that is the output of the system, and this is the basically transfer function. It is the ratio between the output of the system to the input of the system. This is the basically summing point, which is according to the input of the system, and also one feedback loop we have to consider from here. So this is basically closed loop poles and response for the stable system and unstable system. Is it clear, all of you? So is it clear, all of you? The stable system and unstable system. Okay, next, here you can see this is the basically another one. This is a common cause of problems in finding the closed loop poles. This is basically original system. Another one is the equivalent system of the given characteristic equation. So here, this picture here you can see this is the basically one closed loop control system. It is the characteristic equations, input, output, and one feedback loops we have to attach to the summing point here. And when we have to consider this is the equivalent circuit, that is you have to multiply this S into S plus 4, then S plus 6, then S plus 8, then S plus 10. You have to classify it, you have to multiply this one, this one, this one. The equation is coming this pattern, that is 10 into S plus 2 divided by S to the power 5, 28 S to the power 4, 284 s to the power 3, 1232 s to the power 2 plus 121930 s plus 20. So these are the basically state of the plane. So here highest of the poles of the state of the plane, that is a 5. Okay, so this is